Okay.
Perfect.
Recording.
So, hi everybody. So this is the first official, not official sort of meeting of performance team. So I will do. So what I plan for today is that we have some agenda items that I added, last minute agenda items that I wanted to talk about, and before that I want to get aligned on a couple of things before we proceed with what this is, and let's define what this is first. So my main goal for the performance team is to create an environment that we can talk talk anything related to Node.js and performance, and eventually document the process towards what we do, so that new engineers who are interested in opening these kinds of pull requests have some sort of a tutorial way of looking at what those issues are. So yeah, before we start, do you have any questions? Anything you want to say? I don't think so. Okay.
Let's go.
Yeah. Okay, that was fast. So yeah. So for the first issue is the governance meeting schedule that I created. I will drop the link to here. So I wanted to openly discuss how will the performance team should govern, and what should be the interval of the meetings. By default, right now it's 2 weeks, but I just want to get a consensus on what your thoughts about it.
Let's start with 2 weeks and see how it goes.
Yep.
Okay. Okay. So in terms of governance, so right now we don't have anything on the repository. What I wanted to do is that I want to create the similar README to security working group or any other working groups, instead of renaming a work group with team, because we're not officially a work group right now. And when the time comes, we can make that change. But I want to include people that invest their time on this team, and I can start doing that. If anybody wants to take this, and maybe Rafael has more experience about it, maybe you can guide.
Not really, actually. I don't have any experience with governance and so on. Sorry.
Okay. Yeah, no worries. So I will open a pull request. I would be happy if you can review my pull request and contribute on it, because it's going to be a discussion. It's not like a ones or zeros kind of approach. The second thing was that. So let's go back to the second issue, which is confusing licensed MD. So Tobias opened an issue saying that what content is being licensed, who made the decision that the license should be MIT, the copyright holder, Node.js Foundation does not exist anymore. So these are all valid questions. I did that, as you can see from the comment history. I was basically copying security VG's work group's license, and I was reproducing the same thing, but I stopped at a while, and then the license was there. So I think this should be included with the governance model pull request. But taking security working group as a base. So what should be the license of this repository?
It kind of depends on what the content is going to be of this repository. And as we don't really have any content yet, and I don't quite see what content we will be having, is a license necessary?
Yeah.
Go ahead. No, I would say, I think also regardless of what we are creating here, if it's something if it's just Node.js, I think Node.js is pretty well governed under the MIT license. So we should probably just stick with that as a default. And then if we need to adjust that for whatever reason, we can visit that on a case by case, but we should probably just default to whatever Node.js is and then go from there.
Okay, so I suggest removing the license for now, and then we can continue according to our needs. So let's continue towards the issues. So before we dive into what those like optimizations are, I really want to thank everybody for being here. It really matters, and this means that we care about performance. So yeah, okay, we can continue. So one of the issues is this issue number 2 on the repository, which is buffer read-write uint comparison. In 32 array has a higher performance and buffers does not. So one of the most major discussions in the Node community is that should we invest on buffers because there's a native API that does that, and I want to hear your opinions about it.
Well, there are certain things that the buffer API is still faster than what you can have in the web API. And I'm not sure whether those are worth investing in or not.
Yeah.
I see there's a lot of work with text decoder. I was also looking at that, you know, toString and all of these methods on uint 8 arrays seems to be now quite, performance seems to be quite similar. It's the only case I can find now that might be slower is the toString of a subarray. That, as was mentioned in the some issue, that the text decoder doesn't support, you know, just decoding a certain range of a buffer. You have to actually have to allocate a subarray and then send that subarray to the decoder. But other than that, I can't really think of any.
I think for the buffer, we need to cover most of those cases with by establishing a baseline first, right? Like we know that some use cases low, but as you said, we other ones might be faster. So we need really to cover all the steps with benchmarks, because I'm pretty sure we are missing some benchmarks on our CI, right? So I think would be great to, nowadays what happens is that every pull request we run a CI and then someone drop the raw result in the pull request description, right? But we don't have like a way to see the regression or how improvement it got, or I don't know. After this pull request, the performance dropped instead of someone really showing it to us. I think it would be great to, when we establish a baseline for buffers, if we are trying to optimize it, we, I don't know, put in this repository, and then we have a baseline to compare and see if that's work or not, you know.
There is a user, MSC Dex or whatever he's called. He usually, you know, does benchmarks for every commit, and then I guess I'm not sure how much he's still doing that, but it would be nice to have some kind of automated workflow for that, you know, provides automatic warnings when a commit regresses performance of a benchmark by a certain margin.
Yeah, I do have something for very small things on my personal repository, but as I said, yeah, I think it would be great, because that the one that I have does not track regressions. It's only the current state of the runtime. So I think it would be great to track at least the last 3 releases. I think it would be great, yeah.
So what do you think about creating either GitHub workflow or like a build process, so that whenever we release a new version, the new version is compared with the previous version, but only specific parts. So one of the most major issues with the benchmarks CI right now is that it's super slow, and benchmarks are super big because we need to benchmark a lot of edge cases. So if we're going to dive into catching regressions, then we need to classify what matters the most, and we should look into it. And we need to keep our range in a certain part that it's complete in less than 8 hours or 12 hours or whatever that is.
Do the benchmark currently run on all platforms, or is just one platform?
It runs in 3 platforms, as I remember, Linux 64, macOS, and there's one more. I think it's Red Hat. But I would be careful by running a comparison or a benchmark using GitHub workflow, because this is a shared runner, so you might see different
I
things.
was just using GitHub workflow as a trigger mechanism in order to do it, but yeah. So there is Node.js micro benchmark job in Jenkins that we can trigger, which we can compare multiple things. The only missing issue is that the build with parameters only take one category. So if we're going to compare buffers and string decoders and util, then this needs to be 3 different jobs. That might be the case, but this means that the node should be built 3 times. So if we're going to optimize it and improve it, I think we need to support multiple categories as well as multiple filters. I don't know how that is, but yeah.
I think a compromise here could be that we just benchmark Linux for the reoccurring, frequent benchmark runs, and then do the full platform just for release comparisons.
I
Yes,
agree.
that would catch most regressions.
But what are we going to benchmark? Every benchmark script that we have in the repository?
I think only the only that, for instance, that one we have an issue open for buffers. So if we are trying to improve it, we just need buffers benchmarks, and then we keep going, right?
I may be, making this sound easy. It's probably very complicated, but if we do a commit, then we should be able to determine what parts of the code that commit touches and which benchmarks should be run. So if we do a commit changing the buffer code, then only the buffer benchmarks run.
Yeah, the thing I see is, let's say that we have the utils, right? And if someone touches there, we really don't know what will happen, right?
Then we run all of them.
As well as theoretically, it's really good to have this. I don't think practically it's feasible, because a single buffer benchmark that my machine runs in like 5 minutes, it takes 3 hours in benchmark CI. So if we do it for every buffers, which is like buffer benchmarks are really taking a lot of time, that's why nobody's running them. Then we are looking for like maybe more than 24 hours just to benchmark buffers. What I recommend is just to have some sort of what is really important for the ecosystem. Like encoding, decoding might be the issue. File system is really important. I don't know. If we go down this path, we can discuss this further at the next meeting, maybe. I recommend having a list of items, list of subsystems that we want to benchmark, which each releases, and start with that, and then see how much time does it take and how do we catch regressions, and continue implementing that. But again, this sort of puts this team's focus towards towards the benchmarking work group, which I personally don't like, because I think the initial goal for us shouldn't be about catching regressions. I think it should be about improving the most important part of it. So like text encoder, decoder, file system, and like HTTP, HTTPS. Yeah.
But how can we know how we will improve without baseline?
So this is why I created this Node benchmarks repository in my own GitHub account, because I wanted to compare Dino, BAM, and Node. And when you have when you compare those 3 runtimes to each other, you easily see that there's a performance problem. And because V8 and Dino uses the same JS runtime, V8, then it's pretty obvious by just looking at like a 5-minute micro benchmark saying that, okay, Dino had a micro optimization in this particular function and we didn't. So this shows a particular case. And with Bun, Jared is a lot more obsessed towards optimizations, and you can say that, okay, there's a lot that we can do, or you hit a brick wall and say that, okay, this is the WebKit kind of optimization.
I mean, I see your point. I think I'm totally fine if you follow that. I'm just a bit concerned, like, let's say that we invest a considerable amount of time working on optimization for buffer. And then we land a patch, and that's fast right now. But after 2 or 3 releases, still it becomes slow again, and we don't know, we don't have something that will prevent a regression in production, at least not clearly, without asking for micro benchmarks every time.
The tricky part here is what you're asking for makes total sense. Is just that's getting that regression testing and warning, etc., which I think is a good idea, is quite difficult. And should we block progress because of that?
Yeah, that makes sense.
It's one of those difficult situations where, you know, we should do that, but nobody's going to do it, and therefore we're not doing anything.
Yeah, that's reasonable.
We just have to do the best out of this. But yeah, it would be nice if somebody would like to hero the regression like MSC Dex have been doing. But until we have that, I think this node benchmark and just running CI, I mean, nothing is stopping us from running CI every now and then for things we find are important.
Yeah, I totally agree. I think this is a good approach that we should do in the long term. For the short term, I don't want to over exhaust anybody in this team because this is like a really big task, as well as I think it's a little bit too early for us to make these kinds of changes and change how the flow is implemented. But yeah. Are there any other questions or concerns regarding this? Not, we can continue on the fourth issue.
Yep.
So, Ronak, Robert created an issue saying that buffer index of is much slower than even data array index of. So, if you don't have the link to the issue, I will share it in Zoom. Okay. So this was mainly I did a small micro benchmark and look into the code before this meeting, and this was mainly because of buffer's index of implementation, which is a bidirectional index of which supports encoding. And for this particular benchmark, it was using UTF-8, which is 1 byte, and because of that, Uint8 array index of is a lot faster. I found that there's like a fast path for UTF-8 that we can improve if you do an index of on a UTF-8 without any low and high and thresholds. We can improve that. If anybody is interested, I can guide them towards this optimization.
I was thinking the easiest way is just if encoding is undefined and value is a number, then just use the Uint8 array prototype index of.
Yes, that's what I have in mind.
Yep, cool.
So anybody want to contribute this?
Hey, can you hear me?
Yes, yes, we can.
Sorry if it's raining over here, so maybe there's some noise in the background. I was reading the thing you wrote. Isn't it that UTF-8 is like from 1 byte to 4 bytes? Are we confusing that with dating 1 or something like that? Because UTF-8 could have characters in 2, 3, or 4 bytes, I think so. Right?
Yes, you're right. I wrote it wrong. Thank you for the correction.
That should be Latin 1. I don't know.
Yeah, Latin 1 is 1. Yeah, you're right.
Yeah. Okay.
UTF-8.
Yeah, we have to check it's a number and it's not a, yeah, it's within the valid range.
Yeah. In that case was Latin one. Yeah. Sure.
Perfect. So anybody want to champion this?
Yep.
You, Tony?
Yeah. I'm a bit stuck
Perfect.
on the red file stuff that I'm trying to do right now. It could be good to have something to just take a bit of hair.
Yeah.
And
that's good.
let's connect
That's good.
asynchronously for that. And
Okay, perfect. Thank you for taking that. So let's continue on the fifth issue. Atomic condition variable is very slow in V8. So atomics modify. Let me send the link. Atomics modify with atomic weight async is extremely slow. Just doing a normal atomics load and set time mode polling loop is a lot faster. I don't have any experience towards it. And Robert's response was that the benchmarks are tricky due to async stuff. But is there a way to compare this statement of yours?
I mean, I don't know even if this is the right place for it. I was kind of opening different kinds of issues to see what makes sense or not. This is a V8 issue, right? So can we even do anything about it? Are we even interested in implementing our own atomic condition in Node? And if not, I don't think there's much to do. Maybe we could add a note in the documentation pointing out in the Node docs pointing out that, you know, these are slow, use with care. But I'm not sure what else we can do. I was even thinking if we should have some kind of, now I'm going to content, if we should have some kind of new performance guidance for Node. And there we could, you know, point out which APIs are sluggish and why.
that makes sense to maybe have a kind of benchmark and stuff to share with the team, at least to say that we identify it. Maybe they already identify it, but if it's not the case, could be like.
I have created a V8 issue and a V8
okay, neat
as well.
Maybe it's in the link. Okay, thanks.
And there's also Matteo has
compare.
this thread stream repo that is using this kind of hack also to both polyfill and have better performance.
Okay, makes sense.
Have you tried with other runtimes? How they?
No, I haven't.
Okay.
I found this in production last week, so I haven't gotten much further than profiling it and replacing it with a better implementation.
Before we proceed about this, can you share the impact of this performance issue? Like, what is the usage of this particular condition? And like, if we made a significant performance, who and what kind of libraries will be affected by it? And what is the ecosystem impact of it?
Yeah, so I don't know how much the ecosystem is actually using these. I haven't seen any other library that actually uses it. Maybe Piscina that Anna and James did. I haven't actually looked into that. It might be that they use it. So I would say it has pretty low impact on the ecosystem, except for niche cases.
Yeah, normally it's very hard to say how is the impact of something, right? But I do think people really use, at least on my bubble, they use a lot Piscina that might use it, right?
Yeah. I can look at
so I have a question in mind. So should we have a label about some sort of estimation about the ecosystem impact of each issues? So we should have like a more priority towards a particular task.
Does that contribute any value at the moment?
At the moment, so for my personal belief, the main reason that I'm focusing on text encoders and decoders is right now is that it directly impacts a lot of libraries, right? So if there is another issue that is much more urgent than this, and even though it's much more complex, it's going to impact a lot, I would prefer working on that and pushing text encoders and decoders to the like a second phase. But again, this is my personal thought process.
We could have a low impact, high impact label. Wouldn't hurt.
Yeah.
Yeah, or even if we know that there are like tools in the field, in the community, like for RAID 5, we mentioned Webpack and then just have them in the issue. It's not like priority impact, but we could measure the impact by that. Like for example, for the atomics, we have the Pinot logger and we have Pixina. It's too big piece of.
I don't mind to just jump over this issue. I've pinged James and Anna, who are working on Piscina. Maybe we can see if there is any interest for them to discuss the issue, and otherwise, I guess we could just close it if there isn't any other ecosystem impact for this specific issue.
So another question from me: is there a way to? By the way, I think Santiago is leaving. Thank you again for attending. See you soon. So is there a way to search through the most used, let's say 200 npm packages about, let's say, text encoders? Which are those packages are using text? Is there like, do you know any other tool that does this?
Not that I'm aware. I usually just use GitHub search.
You could use GitHub search, and there's, I don't know if code search is public, but at least we probably have enough friends at GitHub where we could get code search access, and then we can search like with some pretty awesome filters, and that could give us at least a lead there. We could also implement something kind of like SitGim or like Canary in the Gold Mine, where we have like a set of like projects that we, you know, maybe we use the set that is in Canary in the Gold Mine, and we say like, is this performance impacting any of these projects, which we've already earmarked as notable or impactful, and then we use that as our shortlist. And again, it's a best effort. You know, we can't index all projects ever, and there's probably also like issues where if we are indexing all projects ever and they happen to be a bunch of personal a bunch of personal React projects that all happen to use a certain Node API as a part of the build tool, is that really what we're looking for versus like general, like who's actually building Node applications and not just using it as a developer tooling part kind of thing? So there's aspects like that. We got to be careful of trying to measure impact and maybe just try and knock things out one at a time as we can get to them.
Yeah, I totally agree, and I think this might be a good case. So this is one of the reasons that I want to communicate with the Webpack's maintainer for today's meeting. Unfortunately, I couldn't. They're not here right now, but I wanted to work on something that impacted a really big, huge project. So that's good. So let's continue to the proposal, and after that, I want to talk about what we can do on the performance side to Undici, and maybe Ethan can help us with that. So regarding the proposal, so while I was working at text encoders, I realized that the ICU developed by IBM is super slow. DNA uses encoding RS. BAM uses their own encoders. They had so they basically had a fast path for UTF-8. Right now, it is landed on our main branch too. So for UTF-8, we are as fast as we can with the V8. But for other encodings and decodings, I recommended ICU. So I recommended encoding RS and ZTD text. But yeah.
How impactful is, I mean, any other encoding than UTF-8?
So I shared a couple of articles that I think one of them had a benchmark which was around 30 to 40% faster. for other encodings. So I don't know the impact of it. This means that we need to ship two different encoders. So IC is required for Intel international format blah blah for V8. So this means that it's going to increase the bundle size as well as like adding a new package. But yeah, this is what I wanted to like discuss, which is not in TSC agenda right now because it's they made the decision that it's a little bit early to put it on an agenda. But if anybody has some strong opinions towards or experience towards ICUs and the performance effects of them, I would be happy to discuss further. Or not, we can push it to the next meeting's agenda. Yeah, let's move it to next week's agenda then. So yeah, so Ethan, if you can help us and inform us about what is the most like bottleneck in DG and what we can do about it, that would be super good.
Awesome. Yeah. And I think Robert will also be a very good resource here. I'm glad he's here on the meeting. But basically, as expressed at like NodeConf EU and whatnot, one of the major things is just it's slow. Fetch is slow generally. It does a lot of things in a not so performant way because it has to. Because again, it's the goal there is like developer experience over actual like performance. It's definitely not the best HTTP API. So there are some things to be said there. I think a big part will be streams and improving the overall performance of streams and buffers, as we're talking about, will help a ton with improving the performance of Undici. And then, yeah, Robert, I'll let you chime in. There's definitely some issues that we can look at too.
Yeah, I mean, it's the web streams that are the primary issue for fetch performance. Other than that, we are doing a lot of things in fetch. We're basically following the spec verbatim. There could be things there to improve. I am a little hesitant to increasing the complexity of the fetch code itself, because the standard evolves. And when you start complicating things and you have to implement standard changes, it becomes very difficult very quickly. So I think web streams would be the low-hanging fruit for fetch. And then I guess it's a question of how do we prioritize fetch and who wants to contribute there?
I did some investigation on that field time ago. And basically, the most expensive part of the node fetch is there are two major failures. The first one is the web strings, because it just follows the spec, but it follows the spec in the JS side. It means that in the head path, even when you finish a request and response string, it will call, let me remember, is the full writer release, which by default, by the spec, it throws an error just to propagate like this end. And creating errors in Node.js, in JavaScript, actually Node.js is pretty expensive. And what people do nowadays is implement the web strings in the C++ side, not in JS side. I've talked with Matteo about it actually several times, and he agreed that, well, that's the reason everybody implemented in the C++ side, because in JS because following the spec, it basically goes against some slow path, actually goes with some slow path of JavaScript itself. So I think if someone wants to be the real hero here, you need to start reinventing the wheel somehow.
Quick
But yeah.
question. How dirty would it be to just allocate the global error and just throwing that?
We can, but only the error is not enough, because basically creating the error is expensive, but the way that the sockets, the strings are implemented, delays. Let me enter in that comment, because I did the investigation. Let me send in the channel too. I did
And
some.
also, sorry, it says Node.js project under your screen. I assume you're Raphael.
Yes, I am.
Yes, thank you.
Yeah, sorry. So let me see. Yeah, we had two problems, actually three problems. The first one is the web strings, but the problem with web strings that, okay, we can touch on that because it's completely optimized the way that is it, because in JavaScript that's all. And then I found, okay, abort signal and abort controller is expensive too. Even when you don't need abort signal, it's created. And then Jameson created a pull request, but it didn't, in the end, it didn't improve the performance at all. And also, the way that we use the transform strings is expensive. I didn't found like a way to improve it because I didn't have much time. But yeah, web strings is the problem. And then we also have a problem with in the lower level, that is the TCP retransmit, which is basically when you are dealing with some package on the TCP, and when some package is dropped during the connection, it needs to retransmit. And when, for instance, when you are using the basic undt-fetch, the package, the module that doesn't follow the spec, by the way, it doesn't call many TCP retransmit. Like as you can see in the link that I passed in the channel, it's basically one or two, that's all by connection. But when you use the TCP, the undt-fetch, it calls a lot of TCP drops and consequently TCP retransmit that basically, as you can see in the clinic doctor, the actival handles going up and down, and basically you are sending way more package than expected in using undt. And the reason for that I didn't find, but I assume that it's completely related to the web strings implementation. That's all.
So I want to share my experience with undt. So a couple of months ago, while I was developing fast query string, I opened the pull request in order to improve the query string module. So if you did a micro benchmark, it is actually 45% faster right now, but somehow in the benchmark it was not showing any improvement, and actually it was making it slower. So I will share the pull request with you. The issue is that right now we're using Chronometro, but it's not an issue with Chronometro. Is that any third-party package that you require is actually slower than native packages. This means that you can't compare apples to apples. So this made me realize that the benchmarks is not in the correct way for undt to have these kinds of things. This is why the pull request is still open. So before diving into what is slow and what is like, I don't know the internals, the specification. I only know the URL parsing specification for now. But I think we need to have a much more broader benchmark right now in order to understand. So the benchmark doesn't even have headers. For example, it doesn't pass header object. It doesn't parse it correctly. So if you do any micro optimizations on that part, it won't get affected by it. But yeah, what are your thoughts about it?
But the thing is, like, we are comparing the same behavior, so that's the problem. For instance, if you use just undt-fetch the module that and you perform the the same approach, it will be faster than the undici.pads implementation, regardless of we are using head headers or not.
Yeah, but if I make an optimization towards how header object is passed to the form data class, then I can't see any kind of improvements, because the benchmark right now in like the benchmark.js doesn't have any headers object in the benchmark, and this is one of the edge cases. Like, we need to make sure that, like, what are we going to benchmark right now? That's what I wanted to ask.
But when you include more things to currently we have in the basic implementation, we know that this is low. If we include more things to that, like headers and other things, you will just include more things to debug, but we already narrowed down the problem to WebStream. When you include headers, probably it will add a lot of noise, right?
I will say from my previous experience, because I actually started with doing headers benchmarking, considering that that's where a lot of like you have this massive object of strings and mappings, and there's a lot of stuff there. It turns out that it's not until you essentially jack up those executions into the tens of thousands that the performance impact means anything. And in reality, fetch requests don't have tens of thousands of header like interactions on a single object. They might have like tens of thousands of header interactions over like tens of thousands of fetch requests, but optimizing like the header's performance at that level just meant nothing. It had much little impact compared to WebStream 6 or utilizing Undici as best as possible, because my first draft of Undici fetch was like, it was using like the request instance instead of the streaming instance or whatever. See you, Robert. So that's something to consider there, is like, as Raphael said, is like, if we've already known what's the limiting factor and what needs to have the most attention, that's where we should spending our time. Any other work might just be a waste of time.
I agree, but for my particular, like for me, I'm speaking from my perspective. I don't know anything about the implementation on Undici part, and in order to make myself comfortable with the code base, I need to start with small optimizations, and then I will lead up to the web streams part. But if the performance, the optimization that we're focusing right now with web streams, it's too vague because I don't know about it. I'm not comfortable with the code base, as well as I don't know what the issue is and what might lead to it. And this is why I'm partitioning the problem into smaller parts in order to create some sort of good first issues, so that we are not the only one focusing on the performance, because like we all have our jobs and we all have our lives, and like if we introduce some sort of small optimizations that new collaborators and contributors can contribute to, then eventually it will lead to big optimizations, and that's what I wanted to say. But again, this is my thought process. Yeah.
Okay. Trying to think. I mean, Undici is very optimized. The nature of it, depending on how you use it. I'm trying to think what the best way to look at this would be from a, like, let's make Undici fetch faster. Is the effort make Undici faster, and then do we get fetch to be faster than that? Or is Raphael's investigation sufficient of like, that's where we need to be looking at? I would say any performance improvements to Undici fetch would be welcome, as long as they are well justified. So like, I think I see like a fast query string one and whatnot, like that would be, if that's something that we could add in there and get some performance benefits, then like we shouldn't block on that. But it clearly, yeah, if we could do web stream improvement, I think that's what will really make or break it.
So if anybody wants to join me, I can be the champion of that. But can you, Ethan, help me and guide me through the code base about what the issues, and like if you can introduce me to the code base, then I can focus on that. because
Which-
web streams. So this might be the most important part from your perspective, and that caught my attention. And let's do that then.
Okay, I'm not familiar with the web streams code. I was more familiar with the fetch implementation, which uses web streams. So that's probably where my knowledge is best put. But regardless, it should be fairly approachable, or whoever wrote the web streams stuff that we're using is probably
James.
someone to talk to. James, then yeah, easy to reach out to.
Okay, I can do that.
I mean, you can. I've worked a bit with web strings too. I have some knowledge, not like James who implemented, but I think, well, it's basically only following the spec, you know, like nothing really different. But yeah, any question you can ask me too if James is busy.
Okay, yeah, let's follow up after this meeting, like in a couple of days, and I will be happy to do it because I was focusing on text encoders, and there isn't any kind of optimization that I can do, and the bottleneck is V8 for now, so I will change my focus to web streams then. So I guess that's it then. Before we close this meeting, like does anybody have anything to say, to contribute? Perfect. So thank you all for coming and have a great day.